Hi, this is Paul Edwards with Danmark Company. How you doing today? Today we're going to go over some training on the BioSecurity Detergent program that Danmark Company makes available to its customers. We're going to try to get as detailed as possible, but remember that I'm always available by telephone. You can call me up and we can talk about concerns or interests or certain things that you may have a question on. But first of all, before I get started, as always, I talk about safety first. This time we're actually live fire, guys. This is, ladies, this is the real thing here. We've got actual chemistry running through the system. And so today it's going to be a little bit different in that we are going to really push safety. You've got to have your safety goggles. You have to have your nitrile gloves, as you can see there, and you also have to have a way of measuring what it is you're working with. Okay, today what I have is a pH paper, and it goes all the way to 14 pH. Okay, so we're going to be looking at pH today because when you talk about biofilm normally has to be pretty much hit with a pH of about 12 and above in order to break that polysaccharide coating. Okay, so that's what we're doing today, is we're taking a look at this chemistry and we're talking about what the pH is, but pH is also a safety issue too, because once you get to above neutral pH and start approaching a corrosive level, then you have parameters that you have to consider, like, okay, what is that going to do to my employees' hands? So should they wear nitrile gloves? Yes, they should. Is there any other concerns? Well, what kind of discharge issues do we have? What do our pH needs to be when we discharge? So keep in mind that, you know, when the pHs that we're going to be working on today, you also have to keep in mind that there's a discharge level that's allowable. You need to find out with your city what that is. If you're going to a lagoon with your discharge, then you're fine, but if you're going into domestic waste or industrial waste, then you may have discharge concerns that you have to deal with. So you may have to look at diluting the stream that's leaving your work area, and you dilute that with water. Okay, so as we go on with this, we'll talk about that. Okay, so the other things that I want you to see is the two products, P and E. The E formula is the wetting agents. It's a proprietary blend of wetting agents, and then the P is the alkaline alkaline agent. And the alkaline agent is also a proprietary blend of things that we're really excited about. All of them fall under the NSF A-1 approval. And NSF A-1 approval means that it's approved for food contact surfaces, and basically followed by a water rinse. So when you use these kind of A1 detergents, you have to realize that once you use it to clean with, then you have to follow it with a water rinse, and then you can sanitize. Okay, you can use a no-rinse sanitizer. One of the no-rinse sanitizers that we use is called Proxene. So here we are, we're looking at the one-button dispenser, and as you recall from previous video, the one-button dispenser is locked in the open position, so it basically stays on. So as you go on and turn on your flow, or you get your flow open by some valve control, then it's going to draw directly from that. Now, one of the things that I want you to do is I also want you to kind of focus on this tips here. You see these tips here, and these tips, they connect directly to this T-fitting here. If you look down here, you'll see the T-fitting here. This T-fitting will accept, you screw in their tips, and then also right up here on the top where it enters the one button dispenser, here at the top, it also accepts tips. So basically what I'm saying is you do have the opportunity to adjust your flow of raw materials through the dispenser. So you have one flow that you're concerned with or interested in is the water flow through this, and the other flow that you're interested in is the flow of the raw materials, okay? And both of those can be managed. The only thing to remember is that you have to have a minimum flow rate as determined by our previous video, is that flow rate has to be a minimum of 2.5 gallons per minute, okay? In a situation where you're dealing with sanitation and sanitizing, that is a reasonable flow rate, okay? 2.5 gallons per minute is a very reasonable flow rate. Now you might be wondering, is that a continuous flow rate? There's a valve that you're turning on and off as you need to apply. So no, it's not continuous. Just means that when the valve is open, you have a flow rate of 2.5 gallons per minute going through there. But when you turn off the valve, then there is no flow at all. And that's the nice ideal situation with this this unit, is that it allows you to do that. So basically what we have is we have two tubings. One tubing is going into the E portion, and the other tubing is going into the P portion. And as you can see, and you follow that tubing up, one is clear and the other one is red. So it coincides with the color of the chemistry in the container. What's really interesting about these two raw materials is they do not homogeneously mix until they make contact with water. So if you were to take the P and the E and you stuck it in a clear glass in raw form out of these containers, they wouldn't mix. You could shake them up, but they would separate out. But once you add water to it, then it becomes a homogeneous blend. E came from the word emulsification, okay? So E originates with the word emulsification, and that's because what it does is it emulsifies the soils. It will wrap a water molecule around the soil that you're trying to clean. P stands for positive emulsion, okay? So P is a positive emulsifier. The reason why we came up with positive is because the pH is such that it breaks up the bond between the soil and the surface it's attached to. So that's how that works, okay? So now what I want to do is I want to go on and bring to your attention that several studies have been done on biofilm. Oh, wait a minute. One other thing I want to go over. The tools that you normally need for tightening these up. Okay, guys? You want to prevent leaking. You want to prevent leaking right here. You're going to need to tighten it up, okay, with two good wrenches so that it doesn't leak here. You also want to tighten up right there, so you need a screwdriver flathead to do that. So I did want to go over the tools, what kind of tools you can anticipate. So right now, I have a positive flow rate onto this system, or at least, no I don't. Okay, so I'm going to hold a second, I'm going to put positive flow rate here. Positive water pressure to this hose. So I'm going to put jump brake. Okay, you see how the hose has filled up with water? That means it has positive pressure on it. I've turned the valve on at the source, and so it's got water pressure built up in there. So what I'm going to do now is I'm going to go and turn on my valve at the outlet side of the hose. Okay, you'll be listening to the solution. Basically what it's doing is it's allowing water to go through the one button dispenser, and that one button dispenser is drawing the chemistry through that tubing there, and then it is filling up a bucket. And so I'm going to demonstrate that bucket and what that looks like. Okay, if you look into the bucket here, you'll see that there's a lot of soap in there. See that soap? You see that? I have it on shower on. Okay, so right now what this is doing is it's filling up my container with the detergent. Okay, and as you can see, it's becoming real foamy. This is a decent foaming detergent, And so basically I'm running it on. I'm going to not fill up 5 gallons, but you see when I turn it off, then I turn it on, I turn it off, I turn it on. When I turn it on, it's running 2.5 gallons per minute. When I turn it off, it's not running it off. What happens sometimes is that if the pressure isn't right, basically what could happen is that you may draw up a certain concentration that you're looking at. So with a good pressure flow through the injector there, or the drawing siphoning device, then you actually can go on and get a higher concentration going through it, because this is all pressure driven. Okay, so with the correct amount of pressure going through, then you're able to get the correct reading that you're looking for. And what we want to do is we want to achieve pretty close to a 12 and above pH is what we're looking for. Okay, we're back. Basically what we discovered is that if you go on and move your head of your output and you put it underneath the solution that you're like, if you have a tank and or a bucket and you have your head underneath the solution, and as it's running through, it sees that head pressure, the injector starts to work unusually wrong. So basically what we did was we filled up the container this time, but without the head being submerged in the solution. And you see the difference right there. You see how we're now operating about a 13 pH. So that's very important that you realize that you do not want to fill a bucket with the head underneath the solution, because that will affect the mechanism that's drawing the chemistry. You want to fill a container with the head of your output above this level. So you don't want to feed into head pressure. It just wants to feed into open atmosphere and then fall into the bucket that you're working with, okay? If you're filling a bucket. In some places what they're going to do is they're going to go on and fill directly into a container that has well, actually on the surface itself. So let's say for example that you're cleaning out an animal confinement area, and you're not going to be working with a bucket. What you're basically doing is you're going to go on and be spraying the floor. So I'm going to pretend that this bucket's the floor. Okay, so I'm going to go on and turn this on. Okay, now you see I have the bucket above it. Okay, great. Now I'm filling it up. Okay, now I'm going to turn it off here in a few minutes. Okay, so I turn it off. Great. Now I've got my container there that's got the soap in it, and it's on the floor. Okay, so I stick it in here on the floor, and then all of a sudden you see that, oh heck, I rubbed the surface off. I shouldn't have done that. Here, let me do this here. The surface comes off real easy. Okay, let's try this here. Try it again. Okay. Okay, there you are. Let me try blowing it off. Yeah, there you go. That's better. Okay, you see that right there? Now we're at 14, okay? We're at 14. And that's with us just holding it above the flow, okay? So that's very important to realize, is that without any kind of head pressure, you're going to be upwards of about 14, 13 pH with this configuration, which is no tips. You might be wondering, okay, Paul, so if I go with no tips, okay, what is my draw rate? What am I drawing out of my raw materials if I go with no tips, okay? Because I may want to put a tip on depending on the answer to your question, you know, or the answer to my question. Okay, well, the first thing you do is you go back into your little metering tip information, and you notice that it says that at 3 gallons per minute and no tips, it's a dilution of 1 to 12. That means for every 12 ounces of water, 1 ounce of your chemistry is added to it. So if you didn't want to be at a 14 pH, if you wanted to move closer to 12, you might be able to put a tip in on each one of these orifices, each one of the sides of the T fitting, because you want to try to keep them even, which is the flow rate being about the same on each. So you may want to go down, and instead of having a 1 to 12 dilution, you may want to have a 1 to 41 dilution. And if you look at 1 to 41 dilution, which is this one right here, that's a blue tip. Or if you look at the 1 by 92 dilution, that's a brown tip. So you may dilute the chemistry based on your preference on the pH, okay? So basically what happened was Danmark Company financed a study on PE5 many years back, and what we did was we used a pH of 12.5 and we looked at Salmonella, Listeria, and E-coli on a stainless steel surface, and we found that with that detergent we had a significant reduction of bacteria. And then when we went in and added the sanitizer to it, the peroxine treatment at the approved range, which remember that any sanitizer could be a D2 no rinse a D2 no rinse sanitizer, meaning that it's a low enough concentration, which in the case of peroxine you can have it as low as 50 parts per million, or as water rinse. It's your choice what you want to do, but I just wanted to basically tell you what you can anticipate. See the foam still in there? That's pretty nice. That's nice foam there. So as you can see that you have a lot of variables you can work with the Danmark biosecurity system, and basically what I did was I showed you how we use a pH paper to determine the minimal amount of alkalinity needed to bust biofilms. Previous research had been done by a competitor company of ours that if you ever wanted to see that biofilm study, they did it, and I have a copy of it, and you're welcome to take a look at it. But it was a very good study, very well done, and they were touting their alkaline detergent and how it did well against biofilms, and so now we're touting our detergent the same way. But going back to PE5, I want to finalize our discussion here with PE5. The nice thing about PE5 is an alkaline detergent that you dilute in your facility. So when you dilute it in your facility, that means that you didn't have to pay freight. You didn't have to pay freight on water, because you left the water out of the chemistry. You were just working with raw materials. So you just saw that with no tips in place at a 1 to 12 dilution, we had a great deal of foam, and we had a great deal of alkalinity at about 14 pH when you don't submerge it in the water. The head of the frontal head, and basically what I'm saying is that this head right here that you see, it was underneath the solution. It was underneath the water right here. So that being underneath the solution, it created a head pressure here, and it prevented the injector to working well. So you have to be real careful with that. But basically what we're saying here is that it's a great detergent program that you don't pay freight on. Whenever you're out in your plant and you need to move a product over to feed this system, you're only dealing with 2.5 gallon containers. You're putting one on one side, one on the other side. They should be drawing exactly the same, but sometimes you may have a difference in draw rate. This may be drawing slower than the other one. So you put a tip in this other one over here, the E, you put a tip in it, and all of a sudden you have the same draw rate, and your pH is fine, your foam is good, your detergent activities are good. We have several customers on this program, PE5 program. They love it, and they save a lot of money on freight. Well, I've gone over a lot of information, but we thank you for your interest. We thank you for your business. And if you have any questions, contact me at 817-822-5767, 817-822-5767, or at our website, www.danmarco.net. That's DANMARCO.net. Or you can reach me at my email address at DANMARCO1 @MSN.com. Thank you very much for your business and your interest.